let's start. I hope everyone can hear me well. If there are any technical issues, we are monitoring the chat as well, so please write there and we are happy to help. Otherwise, thank you everyone for joining to this Future Technology Series Part 2. My name is Peter Eckler. I am Head of Future Technology at Zenitech. And today we will talk about a little bit AI, data science. What are these things? Because nowadays everyone is talking about it, like the OpenAI, ChatGPT, and so on. Let's just try to summarize the main things where and how we can use data science and AI in various software development projects, and what are the key tools, use cases, and technologies. So first of all, these days, AI can do many things. We have seen a lot of examples in different social media platforms or in news, but we are reading, like it can write texts, it can write code, it can create art and images, compose music, make conversations. It's really true. Here you can see some nice examples on the image that there is an AI which is really designed to write convincing texts, and it's pretty good. GitHub has a co-pilot feature. I don't know if you are aware of that, but it helps you to kind of write your code like a co-pilot. It will give you suggestions, a bit more complex suggestions than the IntelliSense, because it works from a strong database. So basically, it's your pair programming partner in an AI-driven way. And we have seen many examples that it can write and draw very nice art. And it's really fun, actually, how the image processing and image creation is done by AI techniques. Anyway, if I may give a personal feeling about it, what was very interesting for me is that nowadays AI is actually fast. So a few years ago or 10 years ago, it was able to do complex things, but it was quite slow. But nowadays, because we have strong cloud technologies, we have very good storage technologies, the processing power is much better. Nowadays, the AI solutions can be very fast. Even we can say that it's real time. So it's really worth to check how we can use it in our projects, in our environment, in our profession, what we are doing. And that's the purpose of this webinar, to talk about how we can use AI and in which situations. First of all, artificial intelligence in general, it's a little bit too high-level word. There is my professor said that there is no such thing as artificial intelligence. So it's not intelligent by its own. We make it intelligent because we give a lot of knowledge to it, a lot of data to it, which it can process. And we give a lot of algorithms, neural networks, decision trees, and based on a lot of knowledge and the algorithms, for some inputs, it can generate some outputs. And that's what we call AI, because all these things are so complex, so many decisions in kind of real time. That's why we call it as an artificial intelligence. If we approach this question a little bit from the technologies point of view, in the data-driven technologies area, there are different roles, different things that we can do, and all of them has its own relevancy. There is this data science technology. The data science is the technology that derives insights from data. Basically, that's the technology how you can understand the data and what you can extract from the data. And when you have the data, when you have extracted the relevant parts of the data, you can make predictive algorithms, you can present connections to the user, you can present the different domains, narrow it down to some specific areas, and really show the value, what you can grab out from the data. Artificial intelligence is another term in theory. That's the theory behind the development of computer science tasks, computer system tasks, which perform kind of operations like human intelligence. So it looks like that it automatically analyzes an object or detects a specific thing on an image, or detects fraudulent activities based on log messages or something like that. But it's also some kind of a data processing. There are some other definitions that belong in this category, like the machine learning. It's kind of the ability which allows the artificial intelligence-based software solutions to learn from the results and to update its current behavior based on feedbacks, like a circular loop. And there is the deep learning, which is a more complex machine learning, a combination of more complex machine learning algorithms with a brain-like logic structure. It uses multiple layers, so you can solve complex problems through multiple neural networks, decision trees, or something like that with that technology. No, it's not always needed, so it's just another technology in this domain. The main use cases where we use AI and data-driven technologies, I have highlighted some on the next slides, and the next part I will show you even more. But just to give you a feeling, it's computer vision. Computer vision uses many times AI-driven technologies, or the time series predictions, predicting the value of something based on some parameters, or predicting the weather is also some kind of an AI and data-driven technology, or clustering, customer segmentation. All these things belong to this category. Another interesting fact that we have to really understand is that it has been said quite a while, even 5 or 10 years ago, that the data is the new oil. And actually, it's kind of true. It's even more true nowadays, because nowadays the AI-based solutions can be very clever and can be very accurate, because they use a lot of data. They have a lot of knowledge, because nowadays we can store and access data more efficiently, much faster. And that's why the oil that we have collected before or during the past years, now we actually are refining it and using it in modern software solutions. That's why it has a huge value, the data itself. If we have accurate data, then we can do accurate predictions. If we have wrong data, bad quality data with a lot of bad and wrong information, then our predicting algorithm will be bad. That's the basic story behind every AI and data-driven solutions, that the quality of the data should be very good. And that's why when you think about an AI project or a data-driven project, you have to think about every aspect of that. And if you really want to deliver a good solution, you need people in multiple roles. You need very strong data engineers who are efficiently collecting the data, filtering the wrong databases, and making it available in a very scalable and very fast way for the applications. You need very good data analysts who are able to understand the data and extract the information from the data, because that's the information is the valuable thing. The data is just a piece of data, numbers and text and so on, or images. But the data analyst is able to extract the informations from the data. And you need data scientists who are able to deliver and deploy and design prediction algorithms, clustering algorithms, image detection algorithms, and any kind of things that you really want to use in your software, whatever software is you are making. So all of these roles are very important and very essential when you create a data science type of project. From another perspective, when we talk about a data-based project or an AI project, there are if that solution is really clever, it means that it has a learning ability. Learning is like in case of human learning, when we are able to update or decision algorithms based on the information what we see in the real world. That's actually learning. And the computer solution, the software solution, is also doing some kind of learning. There are 3 types of learnings. The supervised learning is actually when the machine is how can I say it in a very simple way? So basically, we give a basic knowledge to the solution. So the algorithm is not just running by its own. It has an existing and preloaded data, some labeled examples, And based on that, it is able to start working properly. It's doing very good forecasting, very good diagnostics, image classifications, or whatever solution you need. And it can also learn continuously, but it has a basic knowledge, and it can always be updated with additional labeled knowledge. So we are kind of guiding it how to learn. The unsupervised learning, it's used in other situations when we either don't have pre-knowledge about the environment, or we don't want to kind of determine the algorithm how it should do the classification by its own. We would like the algorithm to discover the possible clustering or discover the possible segments if we talk about the customer segmentations or targeted marketing. So we don't want to guide it as much as in case of the supervised learning. We just want it to learn by its own. And based on the feedbacks, it will be better and better. And the reinforcement learning is the machine learning training method based on rewarding features. So some kind of gamification you can imagine here. It's typically used, for example, in games or in real-time decisions, when it makes a decision and it will immediately get a feedback that this was a good decision or a bad decision, or it gives a negative parameter back because it can work with multiple parameters, and it's kind of always feels how the decision was, and next time it will try to make a better decision, and it will form its decision tree or neural network in a reinforcement way. So these are the 3 typical learning techniques. But anyway, if we want to do something clever, we have to implement some kind of learning solution in our system that we are designing. Let's talk about the situation when there is a new project where we want to do some AI-related development. I will just call it as a data-driven project. It's very important to understand how to start such a project, and it's not easy. It's never easy because software engineers, we write some code, Java code, C++ code, Kotlin code, whatever code, and it's working. But in case of a data project, you really need to understand the business domain. What is the data that you are dealing with? What is the meaning of this number in that table? What is the meaning of the other number in the other table? How are they connected? Or should I kind of enable to compare these values, or they belong to different categories? So anyway, we really need to understand the business. That's how we understand the data that belongs to that business. And we also have to ask the right questions: that is there more data available? Can I access the log files? Can I access the other kind of data? Because if we have more and more data, we can make better AI-related projects or prediction solutions or something like that. Once you have the data, you have to understand what you want to get out from the data. You want to make a good predictions. You need to calculate a very good KPI, and you need to estimate that KPI in the next for the next 10 years or something like that. So you really have to understand the data, and then you have to change the data or transform the data in a way that it should be more efficient for a clustering algorithm or something like that. For example, if you have a lot of numbers but you only have 5 categories, then when you move the data to another location, you have to do some nice data transformations to put it in the right categories, and after that the algorithm can work more efficiently with the 5 category numbers and not with the lot of random numbers. So the accurate data processing is very important, and in such projects, when you have the data prepared, you have to do the models. The models are the kind of the engines which the AI algorithms are using to react or calculate the output, the result from some input data, and the model helps us to the data goes through the model and it will produce the result basically. But it's still not the end, because after that we have to evaluate the result and we have to have a continuous feedback loop. Maybe the result is not something that we wanted, or it's not as accurate as we wanted. Then we have to go back and fine-tune the data preparation, fine-tune the model, whatever we have a chance to fine-tune, and give back the result to the learning algorithm so it can learn from the mistake if there were any mistake, and it will be better next time. From the development maintenance point of view, it needs another approach. We have this DevOps approach in standard software engineering. In case of data-driven projects, it has to be extended. There is this terminology called ML, machine learning operations. You need to remember the different data versions that you have used to train the model. If you need to roll back, you have to be able to access the data set what you have used in a previous version, or if you need to do some debugging. So actually, you need to store also the data, all the versions of the model that your AI algorithms was using to make decisions in the previous versions of the software. So it needs a little bit extended approach from software development point of view as well. And now we have prepared a small poll based on this little introduction. We have a question that hopefully you will answer. Can we start the poll, please? Yes, you see it on the screen. The question is that what do you think, which sector will benefit the most from AI technologies in the future? Agriculture, autonomous driving, robotics, computer vision, retail, marketing, healthcare, insurance, security, or other? What do you think, where it will be used the most in the upcoming years? There are some votes coming. I'm sorry I show it on the screen because it's exciting to watch it in real time, how the answers are arriving. We have some answers. It's very interesting to see that this is what I was kind of expecting, that there will not be a favorite section where it will be used, but actually we see, and you, as I see, you also see that AI will be used in multiple sectors. And I think that's kind of the reality nowadays. They started to use it in healthcare, in marketing. They are already using it in many ways in agriculture, and actually it's coming to every sector. So I guess in security it will also be there soon. AI-driven algorithms will find the fraudsters. They are finding kind of possible penetrations in the system or possible attacks. It can discover an attack even if before the attack has been happened or has been really executed. So it's very exciting. And that's true. AI is coming to every sector. Thank you for your votes. And now let's go back to the slides, because I have collected some high-level use cases where AI can be used. It's some use cases will have a little bit technological background, if you don't mind, but it's very interesting. For example, one interesting area is the real-time analytics. Nowadays, the data is available in a very efficient way, and we can access the data in a very fast way. I would say that we can access the data in real time, and it's very interesting to create real-time analytics and predictions. So, for example, for a forecast, or when you have installed a sensor to a building and you can immediately detect the resonance inside the building or the temperature changes or anything, the real-time analytics is very important. And if you are able to process the data always in real time, you can always show real-time predictions, which can be very beneficial. For example, if your competitors can only do a prediction after a week or after a day, but if you can do it in real time because you use the proper technologies, then your solution can take the lead in the market. Another one is the edge computing. Edge analytics is kind of a method for data collection and analysis that uses automated analytical data that is performed at a sensor or other device. So basically, it means that some kind of calculations and predictions and analytics can be executed locally on the sensors, and you don't need to wait to upload everything to the data centers. Or even if they are uploaded in the data centers, if your solution is fast enough, you can quickly share it with other solutions, and the data that you have collected is kind of available immediately. It's typically used in IoT solutions. Next one is very popular because it's kind of visualizable and we can see it, and it's very cool how it works. It's the computer vision. Computer vision is very popular in AI-related development. There are very good libraries out there. So if you are a software engineer and if you want to do some computer vision, you don't need to start everything from the scratch. There are very good libraries out there that you can use immediately. And these software solutions are used typically to identify and locate objects, read text from images, analyze movement of objects, and all these kind of things. It's a very typical and such a use case which can be used in many different areas. Next use case is predictive analytics and business intelligence. This is typically for decision makers where you need to visualize some trends based on the data that you have collected. And it's not enough just to visualize the trends and the data. You also need to do predictions, and based on the data that you have collected so far, it's very good to predict the revenue for the next year, very good to predict the weather conditions in the upcoming years or months. So predicting and visualizing the trends and the data what we have collected is very useful. And if you have already done it as a first step, you can then add additional functions like pattern recognition, decision making, behavior analysis of your customers, how your users are using your software. For example, a typical use case is the churn detection. When you have a nice software solution, it has a licensing model, people are paying for that solution every month, like, for example, a popular streaming service. It's very important to analyze the behavior of your users in kind of real time and discover or predict if there is a chance that you will start losing this and that user because they are watching the movies less and less. It's good to kind of call those users, give them some extra content or offer them something to keep them within your service. Because if you lose a user, that's what we call the churn. When you lose a user in a subscription model-based solution or from a subscription model-based solution, it's very hard to attract that user or bring that user back to your service. That's why it's important to monitor their behavior and keep them with us. When you develop such a solutions, there are so many technologies out there that we can use. I haven't even listed all of them on this slide, but typically for analysis and different services, we use TensorFlow, Keras, OpenCV for computer vision stuff, and so on and so on. I don't read them. Then for processing, we have nice tools like Kafka Streams, Impala, and many other things. If you need to store the data, and obviously you can use different databases, local and cloud and on-premise installations, and all these kind of combinations. So there are a lot of tools out there. As I mentioned, we don't need to invent the wheel by ourselves again. If we use them efficiently, we can deliver a nice project in a much faster way. So if you are thinking about having a data-driven or AI project, don't think that it takes years to develop. It can take the same time as a simple mobile application. You just need to start working on it, and even within weeks, you can have nice results which are using these technologies. And of course, mobile is always with us, the mobile phones, and I would like to highlight that the modern mobile devices, either iOS or Android, both of them provides a very good engine for machine learning solutions. Android calls it as ML-Kit, iOS calls it as Core ML. They give us face detection, QR code reading, object detection, image labeling, ink recognition, natural language processing. So as a developer, for example, if you need to create an application which identifies the language that I am speaking, Android or iOS gives you an API, and you just need to call a method, give them a recording, and it will tell you what language is that. Or you can use it to extract entities like phone numbers, email addresses, and so on from a text. And actually, Google has a smart reply feature, which is, I think, very cool. So if you give a text and the context, it will kind of automatically try to respond to that request and text. Sorry, as I see, I have a typo on the slides. I will fix it. Don't worry. Thank you. And now let's talk about some example projects, what we have been implemented before, and it might give you an appetite, give you some ideas what kind of projects you would like to implement. And we are also happy with that, to help with that. One interesting project where we have been involved, it's a trading stock market related project, but not with the real stocks. It's in the energy sector. It was designed to predict the price of some kind of energy and how it changes, and it will give some predictions as well. So this project was about visualization, collecting the data, showing the trends efficiently, and doing prediction with an AI-related algorithm. Another one was also prediction. It was predicting the audience, the number of people who are attending on specific events. There were different kind of events, conferences or whatever, and based on so many different parameters like the weather or what was the topic of the event, and many other things, we have created a nice model, and it was able to predict a week before quite accurately, within 15%, how many people will attend on the next event, and based on that you can optimize the capacity, how many entrances should you open to bring in the people efficiently, and all these kind of things. Another one, it was more like computer vision stuff. ID card reading. In every country, the ID cards looks differently. If you need to implement a global solution which works kind of globally, then you have you need to design a really good computer vision solution and teach different images and ID cards. And we have been involved in such a project, and it is able to extract data from the ID cards very efficiently. The next one, it was a very funny one, object detection, classification, and tracking. For example, if there is a specific area that you need to protect because maybe some strange or some important infrastructure is in that area, you install cameras around that area, and you can run smart algorithms on the cameras which are able to identify approaching objects like cars, persons, motorcycles, whatever, and you can track the object. You can just randomly assign a unique ID to the object, and it will track it through as long as this object is around that area that we need to monitor. So it's also a very useful use case, and it will be obviously saved in the database, and so on and so on. I'm not allowed to share all the details how this data was used or why, but this can be implemented nowadays in a smart way. This one, palatal print, it's a little bit related to healthcare. It's a forensic identification based on patterns found on the palatum. You have röntgen images and other type of healthcare related images. Every person has a unique palatal print, and based on that you can identify the person and save medical records in a little bit anonymized way, but still you are able to identify it based on these images and detect anomalies and all these kind of things. So it was also exciting. Another one is a defogging tool. When you have an image and you have a camera and the fog is too high, if you have a smart algorithm, you can basically remove the fog and show a virtual image how that area looks like without the fog. The next one, maybe those of you who are watching this video, you have been participated in similar projects where you need to do some real-time tracking. Like if you have a truck company and you install some GPS sensors on every truck, you need to monitor them in real time. This is something what we have done, but in a little bit different way. In this case, there was a test field, and all the cars which are driving on that test field, their position is monitored in real time. And we had to detect possible collisions, or we have to avoid collisions, and we have to send warnings when two cars are driving in this opposite direction, and if there's a collision warning, or if somebody drives too fast in a specific test area, and so on and so on. So based on the GPS monitoring, we have implemented this real-time monitoring system, and based on the location data, we had to implement different kind of collision avoidance algorithms and many other services. So nowadays, when we collect a lot of data like GPS or position data, this data can be also very used in a smart way to optimize the service that you are providing to your customer. Next one was also a little bit computer vision. It's a traffic sensor. It was also a camera running some code, and it was uploading the images to the cloud as well, and we could use that image in the cloud to run more complex image processing. This was a traffic sensor. It was able to count the cars on the road, to categorize the cars or the objects, like whether it's a car, whether it's a truck, whether it's a motorbike, it's a pedestrian, or it's a bus or something like that. And we were using this data to kind of optimize the crossroads, the roundabouts, how many seconds the light should be green, or how much seconds the light should be red in different locations and in different times of the day. For example, in the morning, in this direction, the green should be much longer, so the cars can use the road more efficiently. The throughput of the road can be much better if you apply such a smart algorithm. So that was also a very interesting project. And this one was also in the smart city domain. That's kind of one of my favorite, because not many people think that in every cities there is an existing infrastructure, but we don't really use too much. And this existing infrastructure is the street lighting. The street lighting is basically there on every roads. And if you install smart sensors on these street lightings, then you can create very good smart city solutions. The huge advantage of the street lightings are that they have electricity because you have the wires there, so you can have a very smart sensor there. You don't need to deal with the battery issues and so on. It always has electricity, and it's actually higher, so you can install cameras, you can install noise detectors and many other things. And we have been participating in such a project where smart sensors were installed on the street lightings. And in real time, we could monitor the traffic, we could monitor the noise, and actually we could give back services to the people living in the city. Like if you want to have a healthy cycling in the city from A to B, this solution can give you an optimized algorithm where the air quality is the best. So it will tell you that do not go on that road because the traffic is high, and based on the air quality sensor, it's the air quality is not so good. You should use another direction because there the air quality is much better. So if you do sport activities, it's healthier for you. If you want to avoid noise, that's also good. But it can be also used to optimize the energy consumption in the evenings. When there is nobody on the road, it can intelligently tell the street lighting to bring down the brightness, and you don't need that much light. But if it detects any car nearby closing to that area, then it can automatically increase the light level, and then the car will see much more, and it's much safer for everyone. Otherwise, it will save energy, but it will not turn off the street lighting because it's important to have some lighting. And you can imagine many other use cases, I think. So this is very interesting. One of the last things that I show is this smart grid data management. Nowadays, everyone is talking about using the energy efficiently. We are installing more and more solar panels at our homes. People are using more and more electric cars, but actually it brings a heavy load to the energy network. It's very hard to keep the network in an optimized way if so many people are consuming and producing energy in random time frames. That's why our smart grid data management solution is kind of helping the energy companies to balance the energy usage and energy consumption. The trafo stations, it will send alerts if there are too many electric car usages in a specific road. If, for example, the energy network is not so good on that region, it will delay the charging of the next electric car if you have already attached 200 cars in that region, it will not allow to charge the next car so fast. It will intelligently optimize the network. Also, it can be true for the energy production. If there are too many solar panels in a specific area, it can detect frauds. So if somebody is maybe stealing the energy and the electricity, it can also detect it. So the whole thing is that nowadays we have more and more smart meters installed in factories, households, everywhere. So we can access the real-time energy consumption and energy production. And based on that, energy companies can create much better services and optimize the network with this data in a much better way. AI and data-driven technologies can be used in sales data processing as well. If you are able to monitor the selling transactions, the buy, the sell stuff in real time, then you can help to predict and the revenue calculations in real time. It can give predictions for the financial numbers and efficient reporting. So that's also very cool. Another interesting project is the propane bottle sales. It's the same domain. Sales is using AI-driven stuff very often nowadays. So when you need to predict how many propane bottles will be sold on a specific location, if you have collected the data and if you load a lot of parameters, dimensions in this kind of service, then it can give you a very good prediction about the propane bottles. And it's very important because it's very expensive to store these propane bottles in the stores. If they are not sold, it's even dangerous. So it's very good to keep as much bottles in the specific location as needed and not more or not less. And one of the last use case that I mentioned is this also in the healthcare industry. If you want to buy a kind of an eyeglasses or in an optic shop, usually these optic shops has a camera called fundus camera, which can make a high resolution photo from the bottom of our eyeballs, and it can see the wires in our eyes, the veins, and it can detect different kind of diseases like diabetes and so on. And in a smart algorithm, it can kind of guide the doctor in a way that if you start the treatment before it's getting worse, you will kind of have a much better chances, and it improves the life quality and so on. So in the healthcare, yes, the healthcare sector also uses the computer vision, image processing, and AI algorithms in a very different ways. And the last thing that I would like to mention is that, for example, here at Zenitech, we also have a product called Sensor Hub, which is around these technologies. We kind of see that nowadays in different sectors, the data collection is very important. That's why we have created this IoT framework called Sensor Hub, where the data can be collected very efficiently. It supports different type of interfaces and database solutions, and it will give a lot of already created analytics module and AI services. So if you are thinking about such a project, you don't need to implement everything from the scratch. We are also not doing that. In many situations, we will use our Sensor Hub framework or part of the framework to give a better and more accurate service to our customers. That was a little bit overview about different use cases where data-driven technologies can be used. I hope it has given you some ideas how to use it in your business sector. And now I just have two closing slides, which kind of tries to wrap how to start dealing with an AI project in your company if you are thinking about trying this technology in your company. First of all, it's very important to understand a little bit what we want to achieve. You have to find areas what you want to improve within your service or a company. I want to increase the revenue. I want to decrease the cost, or I want to predict more accurate customer behavior. I want to predict the customer behavior more accurately. Or so anyway, this is very important to find areas that you want to improve within your service. Then you have to select one or two of the problems that you want to solve, like detect or predict more some values or some KPIs within your service, then I really recommend to create an MVP just to see that are we able to collect the data, are we able to make the data available for our customers. So to make sure that all the technology that is needed to run such a service is available. And once the MVP was successful, you can start building the product and adding more and more features to the product. We have a little bit longer step-by-step guides that helps you if you want to really start working with a data science and AI project. It's more this kind of description. I leave it here a little bit so you can stop the video if you watch it later. But it kind of tells the same thing with a bit more details. You have to understand the data, you have to prepare the data, you need good data analysis and data science operation to extract the information from the data. Then you need to develop the different AI solution, what you want, the prediction model, the clustering model, whatever you like. Then you need a very good visualization, because if you have good results, but you cannot present it, or nobody can see the final number, the predicted number or whatever, or the charts or whatever, then it will not be really useful. So visualization is also very important, very good visualization. And after that, the development and deployment, how it will do the learning, how you will be able to roll back to a previous version, how you will provide QA for such a service, and also continuously to improve the solution based on the feedbacks and analysis what you have when the application was deployed. So that's kind of the steps that you need to take if you want to implement a data-driven solution with different data science and AI technologies. That was all that I wanted to present today. I hope you have enjoyed it, and I hope you have started to think about how to use this technology in your areas. We are happy to help with that as well. And that was all for my presentation today. Thank you very much. If there are any questions, you can write it in the Q&A section in live or in the chat, and I'm happy to answer them right now and even later if you send it to us. Thank you. So I am watching now the chat and the Q&A section. I would be really happy if you can send one or two questions or thoughts that you have, so we can have a little discussion about it. Question is that can our system connect to BMS system? BMS, I thank you for explaining it in building management systems. Well, I don't know which system you mean, the sensor hub, probably. The question is that what kind of building management systems you have. Probably the building management system has some kind of interfaces, like some REST interface or some kind of way how we can send and receive data from that system. When we have designed the sensor hub, we have analyzed the different available interfaces that are typically used in different sectors, and we have made connectors to that. So I'm pretty sure that there is a solution. If not, then luckily we have good experience in software engineering, so we are able to create and add new interface to the system as a plugin. How many projects in Zenitech utilize AR or data science? I don't know if I can tell the exact numbers, and to be honest, I don't even know the exact numbers because Zenitech is has a lot of projects. Luckily, I would say that between 15 and 20, something like that. So not that much compared to what it can be. We see a lot of potentials when we work with our partners, and we see that more and more partners are open to do some discovery work, because to be honest, it's really the future. So somehow it has to be started to use it in different sectors. because it can give market advantage to us if we apply these technologies, and they are not so expensive. So nowadays there are so many good technologies, libraries, modules that we can start using it in the beginning. So we don't need to invest a lot of man days to have the first results. And thank you for the question. Yeah, Ryan asked, and another question, that if a building has a software, can we pull the data? I think yes, definitely. We can discuss about different approaches. We have seen similar solutions. Okay, thank you for the questions. They are very good.